Hey everybody, in this next video lesson we're going to talk about something called a phase diagram. Now what is a phase diagram? It's a graph, as you can see, that plots on the horizontal temperature increasing to the right and pressure increasing along the vertical axis. Basically what we're looking at is the pressure versus temperature graph of a substance, and we're talking about the transitions between solids, liquids, and gases. Now, up until this point, you probably only thought that temperature played a role in transitioning from solid to liquid to gas, but pressure can also play a role in that transition. You may have seen me take room temperature water and actually lower the pressure and get it to go from a liquid to a vapor, or essentially boil it by lowering the pressure without increasing the temperature. So some important parts of the phase diagram. First of all, we've got the area which is known as a solid, the liquid, and then the vapor or gas section down here. T is known as the triple point, and it is a very specific, very theoretical spot in which you can have all three states of matter existing at the same time. It's a specific temperature and pressure at which solid, liquid, and gas exist at the same place at the same time. It is kind of fun to see, and I'm going to show you a little video clip here in a second about how you can lower the pressure and the temperature to reach a triple point of a particular substance. This is known as the critical point. And this is a point of temperature and pressure in which anything warmer or anything higher pressure actually achieves states of matter that we're not going to talk about too much in this class. These are like your plasmas up here. The critical point, anything colder than that would be a liquid, and anything lower in pressure than that would be a vapor. But anything above that temperature and pressure is in this no man's land, which we, once again, won't talk about very much in this class. What about the transition states between solid and liquid? Well, when you're going from solid to liquid, we call that melting, and the opposite would be freezing. What about going from liquid to vapor? Well, we call that boiling or evaporation, and going from vapor to liquid, we call that condensation. But what about this point where the pressure is low enough and the temperature is low enough where a solid actually skips the liquid state and goes right to vapor? This is a vocabulary word that you're going to need to know, and it's called sublimation. Sublimation means to go from solid to vapor, and the opposite of going from vapor to solid is called deposition, or to deposit. This is what happens when snow forms in the upper atmosphere. It takes water vapor and it deposits into snowflakes and then falls down. Sublimation and deposition are transitioning from solid to vapor and vapor to solid. I got a few video clips here that I want you to check out that shows a substance that reaches its triple point, and we'll also take a look at sublimation and deposition.
Here is a video on kind of accessing this triple point, and there's no audio to it, so I'm actually going to talk over it as it kind of works here. So inside of here, we have TBO alcohol that is being put through a vacuum. So it's actually reducing pressure. So you don't see the vacuum in the video, but we're actually reducing the pressure. So as you see, at some point, the pressure drops enough where we get it to boil, okay, just like we did in class. Okay, so we now have a boiling alcohol, and as this thing is boiling, it works fine at first, but then what happens is after about 30 seconds, something kind of unique happens here, that the actual boiling, it actually stops. So if you notice here, it's going to actually stop boiling. Okay, and the reason why it's stopping, it actually hits that that boiling point, and it starts to kind of get colder, because as you are actually boiling, you're also cooling it down, right? Because it's a cooling process. So after 2 minutes, then you start to see this happen. Okay, so we actually see that it's actually starting to freeze up on our screen. Now, it's also freezing, but wait, it's also boiling. Okay, so what you're seeing here is that triple point. This is the point at which we get both freezing, boiling, vaporization, deposition, all that stuff happening all at the same time. It's that magical spot where all three can exist at the same time. Now, because they're putting this through a vacuum, eventually it'll all turn into a solid. But we do get a chance to see solid, liquid, and gas all at the same time. Okay, probably never seen something freeze and boil at the same time before. Okay, which makes sense because you've never actually messed with both temperature and pressure before in the system. So this only works because we're using a vacuum inside of this stuff.
We're going to form some liquid carbon dioxide by simply taking a hunk of solid carbon dioxide, or dry ice, and beating on it with a hammer. We want to smash the dry ice into a really nice fine powder that we're going to actually stick inside a container. and build up about 5 atmospheres of pressure, turn it into a liquid. So in order to do this, we've got a small plastic pipette. We're going to snip the top end off so that we have a nice opening. That'll allow us to pack in a good amount of this dry ice right inside there. We've got a pair of gloves on here so we don't touch the 109 degrees below zero dry ice. Get a really nice clump of solid carbon dioxide inside the bulb of the pipette. And in order to warm this up, we're going to use a glass of warm water. And to build up the 5 atmospheres of pressure, we'll simply crimp the top of the pipette with a pair of needle nose pliers. It's a little tricky with the gloves. Takes a little bit of work here, but we're going to seal the top nice and tight, hold it with a pair of pliers, and then simply dunk that pipette right into the warm water. Warm water will start to warm up the carbon dioxide, and we'll see it changing right from a solid into a liquid. And as we build up about 5 atmospheres of pressure, the pipette's going to burst, and instantly it'll go right back into that solid phase. So we've got some solid carbon dioxide right there.
So now we're looking at a labeled phase diagram for water. And as you can see, at 1 atmosphere of pressure, 101,000 pascals, which is standard atmospheric pressure, the temperature at which water goes from solid to liquid is, well, 0 degrees, as you can see labeled in red. And the temperature at which it goes from liquid to vapor is 100 degrees Celsius. So we've got at 1 atmosphere of pressure, 0 and 100. But the triple point for water is actually very, very low in terms of pressure. We're talking about pressures that are really, really small, 0.006, and the temperature is about 0 degrees Celsius, just a hair or temperature above that. And that triple point, at that point, water exists as a solid, liquid, and gas. But once again, that's kind of theoretical, and I showed you that video just a second ago. That was for a specific type of alcohol. We don't really ever mess around with pressures, because imagine getting a pressure that small. 1,000 times less than the atmospheric pressure. We're talking about pressures that are really, 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 really small. Now, if you increase the pressure to 218 atmospheres, or 218 times the atmospheric pressure of Earth's atmosphere, and you increase the temperature to really, really warm, and it's difficult to see this temperature behind here, but it's pretty hot. I think it's 300 degrees Celsius. You reach the critical point, which anything that's warmer or above that is in that no man's land, which we call a plasma, which is the state of matter that you can achieve only on the outer space, like on stars and stuff. It's important to note, once again, that this phase diagram is very specific for just water. If we had a different substance, these temperatures at which you transition from solid to liquid and liquid to vapor, and these pressures, this whole phase diagram would look completely different. So don't just assume everything looks like this. This is specific for water. Well, that takes care of this video lesson. Thanks for watching.